Hi everyone, welcome to Learning Math with VK. Today we explore lesson 31 in algebra, applications of exponential equations in finance and physics. 1. Applications in finance. A family invests $10,000 into S&P 500 for their child toward college. S&P 500 has a return rate of 8% compounded annually. Find the amount in their account after 18 years. To do this one, we're gonna use the compound interest formula. AT equal to P times 1 plus R over N to the power NT. P here is the initial investment. So 10,000, that's P. 8% annual return rate, that's R. Compounded annually. N equal 1. 18 years, that is T. And so what we do is just do the substitution. And we get 10,000 times 1 plus 8% is 0.08 over, and it's 1 times 18. Remember, I put a note here. N percent is N over 100. So 8% is 8 over 100, which is 0.08. 80% will be 80 over 100, 0.8. You can just plug this in the calculator. This is the calculator that I want to show you. Let's use that's most scientific calculator. Let's plug it in. 10,000, 1 plus 0.08 over 1. Pretty cool, huh? To the power 1 times 18. Ta-da! $39,960.19. Pretty good money. $39,960.19. Let's go to the next one. Let's take a look at the second example. A worker wants to save money toward retirement. The worker invests $50,000 into Google stock that have a 10-year average annual return of 15%. How many years does it take for the account to grow to $5 million? We use the same formula, compound interest formula. Compound interest formula. AT is P1 plus over N to the power NT. Let's take a look. Initial investment, that would be P. Return of 15%, that is interest rate, or annual return. So that is the compound rate annually, N equal 1. Usually when you do stock investment, you get annual return. Stock is compounded annually. We have another information. $5 million. That is A of T. What we don't have here is T, and that is what we want to answer. How many years? That's T. We can do the substitution and solve for T. Because after we do the sub, let's take a look. 5 million equal to 50,000. 1 plus 0.15 over 1 times T. We have one equation with one unknown. We can solve for T. Divide both sides by 50,000. And we have 100 equal 1.05, 1.15 to the power T. This is the exponential equation. We can move the exponent down using ln. Hit ln on both sides. ln 100, ln 1.15 to the power T. And we have ln 100. Here we use the power rule. T times ln 1.15. Yeah. Divide both sides by ln 1.15, and ta-da, we have T to be ln 100 over ln 1.15, which is 32.95, approximately 33 years. Pretty cool, huh? Hopefully, Google is still alive in 33 years. Let's move on to application in physics. A hot soup at temperature 212 degrees F, that is boiling temperature, is placed on a table in the kitchen at room temperature of 70 degrees F. After 10 minutes, the temperature of the soup pot is 180 degrees F. How long does it take for the soup pot to cool down to 120 degrees F? A desirable safe temperature to eat. To do this problem, we'll be using a different formula. This is a very important formula for cooling down in physics, and it is Newton law of cooling. Well, we have TT equal to TS plus D sub 0 E negative KT. Yeah. T of T, that is temperature after T. Here it's going to be minute. TS is surrounding temperature. And D sub 0 is the initial temperature difference. K is a positive constant. It's a positive number. Okay, so this is the formula of Newton's law of cooling. Let's see how we're going to use it to solve this problem. A hot soup at temperature 210 degree F. So this 210 here is a very important number. It's placed in the kitchen at room temperature of 70 degree F. So 70 degree F here. The difference between these two numbers is D sub 0. So we have D sub 0 is 212 minus 70, which is 142. The number 70 here is the surrounding temperature. Yeah. Another information that we can use is after 10 minutes, the temperature of the soup is 180 degree F. The temperature after 10 minutes is 180. We can use this one to solve for K, because once we do the substitution, you will see that TT is surrounding temperature 70. D sub 0 initial difference 142 e to the negative KT. In order to use the formula, we have to solve for K. We're gonna use T of 10 equal 180 to solve for K. Okay, let's do the substitution. 180 is 70 plus 142 e to the negative K times 10. Minus 70 on both sides. We have 110 equal to 142 e to the negative 10K. To isolate the exponent, we divide both sides by 142. 110 over 142 equal e to the negative 10K. To get rid of e, we can take ln on both sides. ln. We have ln 110 over 142 equal negative 10K. And then from here, multiply both sides by 1 over negative 10. It is a little bit better than divider. Because they look better when you put it in the calculator. So now we have K is equal to, punch this one in the calculator, and ta-da! We have 0.0255. So that's K. Once we have K, then we have the function TT equal to 70 plus 142 e to the negative 0.0255 t. We can figure out how long it takes for the soup to cool down to 120 degree F. To find how long it takes for soup to cool down to 120 degree F, we let TT equal to 120. So we're gonna do the sub. 120 equals 70 plus 142 e to the negative 0.0255 t. Now we have an exponential equation. We can solve for t. Minus 70 on both sides, and we have 142 e to the negative 0.0255 t equal to 50. Divide both sides by 142, so 50 over 142 is e to the negative 0.0255 t. Get rid of e. We need to take ln on both sides. And ta-da! Negative 0.0255 t equal to ln 50 over 142. Next, divide both sides by negative 0.0255 or multiply by negative 1 over 0.255, and we have t. T is negative 1 over 0.0255 multiply to ln 50 over 142. Plug this in the calculator and that is 40.93, approximately 41 minutes. Oh, a long time to wait. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I'll see you in the next video.